Welcome to part 3 of Competency 3. In this video, we will work with the laws of exponents. Okay, before we begin, there's some laws of exponents that are handy to know, even though your calculator will handle a lot of this for you, a lot of the heavy lifting, you still need to know the properties themselves. So again, if this isn't something you're used to, you need to go brush up on this. Go find a good video, your old notes, whatever you need to do. Okay, so let's begin with number 1. Okay, we have 3 here. Number 1, which of the following is not equivalent to -3 squared? Now, the point of this is that the -3 is in the parentheses. Okay, so let's put in -3 and square it. What do we get? -9. Okay, now let's put in the given parentheses, -3, close parentheses, and square. Notice that that's different. Okay, you should be aware of this fact. And we are looking for what is not equivalent. Okay, when it's in parentheses, that means we're squaring the negative also. And a negative times a negative is a positive. Okay, B is equivalent because 3 times 3 is 9. And then C is equivalent because it shows the process. And D, again, is still 3 times 3. And -3 times -3, same thing. It's all 9. Okay, let's look at number 2. What is the value of, oh, goodness gracious, we have -2 to the 0 times -2 to the third times -2 to the fourth, all divided, no, just a division, not all divided, but divided by 2/3 squared. Okay, that's a put it in the calculator if I've ever seen one. Okay, so we have parentheses and -2, carry it up to the 0 power, arrow over, then times, parentheses, -2, close the parentheses, carry it up to the third. Remember to arrow over. If you're not squaring, you always have to arrow over, right? Times, and I have found that's true in the TI-84 also. Okay, we did that one now. -2, close it, and that's carried up to the fourth power, arrow over. Now we have to push our division, and we need parentheses, fraction 2 over the 3, go over, close it, and we can simply square that one. Okay. And if you're not sure if you entered everything correctly, remember you can use your arrows back and forth, left and right, to go double check. And I'm good. All right, let's push enter. And there we go. Option B. Nice. Okay. All right. Let's look at number 3. Which of the following is not equivalent to 4 to the 2/3 power? Oh, goodness. Okay, we could put that in the calculator, but there's something that I need to make you aware of. Okay? And I'll just show you with a square and square root. Okay? If I have x squared, the truth is that that is undone by the square root, right? Well, what is the square root of anything? Okay. Well, the truth is there is an understood 2 there. Okay. All right. So now let's look at just simply the square root of x. Okay. Well, this is actually equal to this. You have a 1 here and a 2, understood 2 here. So that is equal to x to the 1/2. Okay, now look at where the 2 is. The 2 is the denominator, and the 1 is the numerator. Now, let's do that here. 4 is the base. Okay, now let's look at our denominator. Here, let me highlight that. Okay, our denominator is 3 here. And here we have 2 and 2. Okay, all right. So that means that I need, for my purposes, I'm using a cube root. So I need a 3 there. And the numerator goes with the 4. It goes with the 4 as the exponent that stays. Okay. Now, let's look at what we have that is not equivalent. Well, obviously A's equivalent, so that's not going to work. Well, let's look at B. What is 4 squared? 4 squared is 16. That is equivalent. Okay, now we could also put these in the calculator. Okay, and then we're going to have to do that. I'm thinking C is not, but we're going to have to put it in the calculator to get D. All right, so what do we do? Clear everything out here so you can see what I'm up to. When you're cubing, when you're doing anything but just a square root, cubed to the 4th root, whatever you're doing, you have to push the value of the root first, then second, and the caret up button because above that. So you have your unknown cube. So we have it set up. And now, okay, I have 4 caret up, square it. Okay, there's my decimal. Okay, now let me put in the given the way we saw it. 4 caret up, put in my fraction, and that is 2 over the 3. And again, so that proves everything that I'm doing. 1, I showed that A is equivalent. I showed that D is equivalent. The only one that I didn't show yet is A. Well, we're pretty sure that is, well, I kind of sort of showed it. So 3 and then second, and I need my unknown root button, okay? And then just pop in a 16, and yes, it is equivalent. So obviously C in that form would not be equivalent. Okay, let's move to number 4. Number 4, what is the value of 4 to the negative 2? Okay, if you know your properties, you already see which one is correct, okay? But let's put in our given 4 to the negative 2. Push enter. Okay, I don't see anything here. I do see something that looks suspiciously like it. Okay, and that is B. And why do I say that? Well, what is 4 to the second power? 4 times 4 is 16. So I'm thinking it's probably B, but let's keep going. Push your toggle button. Now, when you push the toggle, you see C and D. These two decimals are obviously not what we have in our calculator, so we know those are wrong. So now we're down to A and B. Makes B look a lot better. But why is A incorrect? Well, that is, if you look at it, how can it be? You can't just take 4 to the negative 2 and pop it down into a denominator and saying it's the same. And if we put it in our calculator, we'll see that that just doesn't make sense. Okay, 4 caret up negative 2. It's just 16. So that's obviously not equivalent. B is verified. Let's look at number 5. What is the value of, oh, and I have this mouthful of an expression. Let's just put that in the calculator. Clear that out. And parentheses. Okay, our fraction is 1 over 3. Close your parentheses. Now caret up, negative 3. Oh, I didn't close my parentheses. I can go back and type it in. It lets you do that when you use exponents. Okay. And then you have to arrow all the way over, subtraction, open my parentheses. I have 2, carry it up to the 3. Arrow over, close my parentheses, carry it up, and that is again to the third. Notice how it lifts it up a little. Then you have to arrow over all the way, and I see division, and that is 16, carry it up, make a fraction, and then 3 over the 2. And let me kind of look back. Did I do that right? And I like what I entered, so let's push enter. And it is 19. That is A. Okay, that's just a situation of let's enter it. All right, let's go up. Let's look at number 6. Which of the following is not equivalent to 3 to the 6 over 3 to the 11? Okay, I'm saying A. Remember, we want the not. I'm saying A. Why am I saying A? It is Captain Obvious blaring us in the face. 3 is a whole number, and a whole number to the power of 17, that is going to be a very large value. Okay? When I build my fraction and I say 3 carried up to the 6, and then I'd say 3 carried up to the 11. Okay, I like it. Makes verify my entry, push enter, and that gives me a fraction with a large denominator, and I push my toggle. That's a decimal. And 3 carried up to 17, like I said, is a very large whole number. There's no way. Okay, so option A has to be it. And how do I know this? Well, if you know your properties of exponents and fractions, this base, because the base is the same for my numerator and my denominator, this gives me permission to say 6 minus 11 equals 3. That's 3 to the 6 minus 11, which gives me negative 5, which equals 1 over 3 to the 5. Okay, that is everything I just wrote is how you solve for an exponential fraction with the same base. So obviously those are not it. Okay. Now let's look at number 7. Which of the following best shows the laws that explain why a to the negative 1 equals 1 over a to the first, which equals 1 over a? Okay. Let's evaluate these. Okay. Let's look at A. A gives me a fraction, and then A is basically what we just did in number 6. It goes through the process. Well, that's not an explanation, that's a process. I'm going to mark that out for now because I'm not believing it. Now let's look at B. B tells me that x to the first is just x, and x squared is x times x. And then you don't see it, but they use cancellation, which gives you 1 over x. I believe that. I buy that. That works for me. But let's look at C. C says x with 1 minus 2 gives you x minus 1, which equals x to the first over x to the squared. That's like a backward process or a mixed process. That doesn't make sense. I mean, it does make sense, but it's a process. It's some kind of an explanation of the process or the process out of order or something like A. It's A out of order. So I'm not believing that one. But let's look at D. D begins with B, and then it says, "Hey, look at what we did here." It goes up and shows you the process. So it gives you cancellation and then goes with, notice how these are the same? So it says, hey, you're starting with the same thing and you're ending up with two different results. So they must be equal. Okay, now that I believe in D is out because, I mean, B, because B is part of D. Okay, I believe that. I'll say that that is definitely it. Okay, this is the last question in this video. Thank you for watching to the end. And I truly appreciate everyone who's been subscribing. You guys are awesome. Happy testing.